Uh, good, good evening, guys. Good evening, guys. I hope that all of you, can you guys see my screen, guys?
Yes.
Yes, sir.
Okay. Thank you very much. So let us continue. So I'm just gonna do two more simplification problems involving laws of exponents, right? So now we are given this expression. The question says, let me choose my pen, the thickness. Yes. It says 1 over x plus x over y, all raised to the exponent of negative 2, right? So what do? We see that we have a sum of two fractions inside the brackets as the base of this exponent, right? So we can first start by simplifying what is inside the brackets. So we can, okay, we have something like this. We have 1 over x plus x over y, all to the exponent of negative 2, right? So what is inside the bracket is a sum of two fractions. And we know that if in case we want to add two fractions, we have to find their lowest common denominator. And in this case, it's going to be what? X multiplied by what? By y, right? So I'm continuing now. So this is going to be xy all, and then it's gonna be what? Y plus x squared, right? All to the exponent of what? Negative 2. And now what am I going to do? I now have this whole base. So this means that I have now what? I have a numerator and a denominator. But I have to make this exponent to be positive. So what do? There's a law that we learned about yesterday, whereby we said if in case you want the exponent to be positive, you swap the numerator and the denominator. So that's where now we are going to do this. So when I swap, I'm gonna have xy all over y plus x squared. And all of this now raised to the exponent of what? 2. This is where so the exponent is now positive. So once we are here, what do we now do? Remember, there's this law. There's this law that says now, if in case I have a numerator divided by denominator, all raised to a common exponent, I can keep the numerator and give it the exponent, that furthest exponent. Even for the denominator, I can keep the denominator and give it the what? The exponent. So even here, I'm going to apply the very same thing because check, I have a numerator and a denominator. I'm just going to simplify it to what? To x, y, that's the base, and I'm going to give it the exponent of what? 2 divided by, I'm going to take the denominator, which is y plus x squared, and I'm going to give it all the exponent of what? 2. And then I can continue to simplify this by saying, okay, I have x times y. This is multiplication here in between, right? X times y, all raised to the exponent of what? 2. These are not the same bases. This is a base of x, this is a base of y. So we are not adding the exponents. But we do remember that there's a law that says whenever we are multiplying two different bases, all raised to a common exponent, we can what? We can do this. There's this law. We can what? We can keep the base and give it the exponent, and we can take that other base and give it the exponent, and then we still have the multiplication sign in what? In between. So We are going to apply that law. So this means I'm going to have what? I'm going to give it the exponent of 2 and times y to the exponent of what? 2. I still keep the multiplication sign in between, all divided by. So here, you know that what I have on at the bottom is just x squared plus y, all what? Squared. And here, you know, it's just simple what? You are multiplying two what? Two brackets, x squared plus y multiply by x squared plus y. And you know for this, that's whereby we use the FOIL method. We use the FOIL method, right? So we are going to multiply the first terms, x squared and x squared. This is going to give us how much? X to the exponent of what? 4. Because this is the same basis and we are going to add the exponents. And then I'm now going to multiply the outer terms, which is x squared times y. It's going to be what? Plus x squared y. And I'm going to multiply the inner terms, x squared by y. It's going to give me another plus x squared y. And then I'm going to have the last terms. So I'm going to have y times y, which is going to be plus y squared. And then this is all going to be what? X to the exponent of 4. It has no other like term, but these two are like terms, so I can add them. So I'm going to have plus 2x squared y plus y squared. So that's what now I can put as my denominator. So I'm going to take this, I'm going to take that, I'm going to take that, and now put it as my denominator there. So let me continue and put it there. So I'm going to have all x4 plus 2x squared y plus y squared. So that, guys, is the final answer because there's no more simplification that we can do. Remember that here it's multiplication. This dot represents multiplication. So there's nothing that we can do to simplify this problem further. So that is our final answer. So question, are you guys now satisfied with the solution? Guys,
Yes, sir. Yes.
is there a certain step that you guys don't understand? This is the perfect time to ask questions. Whenever I'm done solving a problem, you can ask questions. So this is a perfect time to ask questions if in case you have any. Guys, uh, Amante, are you okay? Do you understand the problem?
Yes, I understand.
Okay. Sharon, do you understand the problem? You can unmute yourself. You understand. You can just make a thumbs up. And just make a thumbs. You understand. Chioma, do you understand?
Yes, I understand.
Okay. Tsiamo, do you understand?
Yes, I understand.
Mashudu,
I understand.
Yes, I understand.
Mashudu, you understand?
Yes, I do.
Okay. Mashudu, are you in the dark?
Yes, I think
Okay,
so.
I'm really sorry. Okay. So let us continue, guys. Let me now go back to here. So I'm gonna take now one last problem. Assuming that you guys now understand that one, I'm going to take up one last problem. I want to do a similar one to the one that we did yesterday. I think letter I will be good. This one. A good reminder of a problem that we did yesterday. So that's the other problem that we have, right? So guys, for such problems, I gave you guys advice yesterday that, okay, before you continue with such problems, just look at the numbers that you have and then you find the factors of them. So I'm going to take 8, right? I'm going to put it into my Casio calculator. I'm going to say 8. I'm going to press 8 and then say equal sign and then press shift and then the factor button. So 8 can be expressed as what? As 2 to the exponent of what? 3. Okay. And then I now look at the other number, which is 4. So I'm going to have 4 and then I'm going to press 4 in my Casio calculator and say equal sign and then again say shift and then factor. And then I'm going to have 4 as its factor. It's going to be 2 to the exponent of what? 2. And then now 2 is just simply okay. It's just simply okay. 2 itself, it's just 2 to the exponent of what? Of 1. So everything is fine. So now, wherever I see these numbers, I can just substitute the numbers on the right. You see these numbers. So where I see 8, I'm going to substitute 2 to the exponent of what? Of 3. Where I see 4, I'm going to substitute 2 to the exponent of 2. Where I see 2, I can put in 2 to the exponent of what? Of 1. So let me continue with what I just said. So I see where I see 8, I'm going to have 2 to the exponent of what? 3. All to the exponent of what? 2x plus 1. Plus, where I see 4, I'm going to have 2 to the exponent of what? 2. All to the exponent of what? 3x minus 1. All over 2 to the exponent of 1. All to the exponent of what? Of 3x. Are we guys okay? Let's continue. So now, you know that whenever I have a number raised to a certain exponent, and then again, this number raised to the exponent of 3, it's also raised to the exponent of what? 2x plus 1. That's where I now multiply the what? The exponent. So I'm going to have 2. I keep the base and I'm going to multiply the exponent. So I'm going to have 3 multiplied by 2x plus 1. Right? And I have plus. Even here, I still have the same case. I have 2 to the exponent of 2. So I keep the 2 and then I multiply the exponent. So I'm going to have 2 times 3x minus 1. I put it inside brackets. Right? All over. Here I'm going to have 2. I keep the base. I multiply the exponents, which is 1 times 3x, which is just 3x. Right? And then I continue at the top. So what am I going to have? 3 times 2x plus 1. I'm going to have 2. I keep the base. So I'm going to have 6x plus 3 plus 2. Now I multiply 2 by 3x minus 1. So I'm going to have 6x minus 2 all over 2 to the exponent of what? 3x. Are we guys now okay?
Yes, sir.
Yeah, okay. So now
Yes.
I wanna remind you guys of something. I wanna remind you guys of something. Remember that whenever I have something like this, A plus B all over C, it can just be expressed as what? A over C plus B over C. Whenever I have a plus or a minus sign. So even when I have A minus B all over C, I can just say it's A over C minus B over C. Right? Whenever I have a plus or a minus sign, I can separate all over the common denominator. But whenever I have what? A times B over C, this one I can just break it down as what? A over B. Oh, sorry. Let me erase. So I can break it down as being A over C times what? B. Or I can express it as being what? Equal to A multiplied by what? By B over C. So whenever I have multiplication, I can just choose which number I want to divide the denominator by. So here, I can just take it as what? As I can choose to divide A by C and then multiply it by what? By B, because I have multiplication in between. So whenever I have multiplication, I don't have to divide both terms by the common denominator. But whenever I have minus or plus, I have to divide both terms by the denominator and keep the what? The sign. So whenever I have multiplication, I can just choose one number to divide by the denominator and still keep the what? The sign. So whenever you have plus or minus, you divide both terms by the denominator and still keep the sign. Whenever you have multiplication, you just take one number, divide it. You just choose which number you want to divide and then still multiply by the what? By the other number. So you don't divide both of them by the denominator, but then you still keep the sign of multiplication. Are we guys okay? So these are just
Yes, sir.
basic things from your grade 4 mathematics, right?
Yes, sir.
Yes. So let's continue. So here, what will I do? I'm going to apply this law of adding, right? So I'm going to have now 2 to the exponent of what? 6x plus 3 all over the denominator, which is 2 to the exponent of what? 3x plus what? 2 to the exponent of what? 6x minus 2 all over 2 to the exponent of what? 3x, right? So check now. What is it that we have? I have the same base. The same base. And I'm dividing. So what will happen? What will happen is that I can now what? I will keep the base and then subtract the exponent. So it's going to be 6x plus 3 minus, I put the, you see, and then plus, I come to this one now. I check now. Check, I still also have the same base. The same base. So I can just simply subtract the exponents. So this is what I will have. I will keep the base and then still have the exponent of 6x minus 2 minus, I put the bottom exponent into a bracket, so 3x. Now I just simplify. And so I'm going to have now what? 2 to the exponent of what? 6x plus 3 minus 3x plus 2 to the exponent of 6x minus 2 minus 3x, right? So I'm going to have now 6x minus 3x. It's going to be 2 to the exponent of what? 3x plus 3. Here I'm going to have plus 2 to the exponent of what? 3x minus 2. Is that okay? That is okay, guys,
Yes.
right?
Yes, sir. Yes, sir.
But then remember that this term that we have, remember there's this law that says, okay, if in case I have a to the exponent of b plus c, this thing can just be expressed as a to the exponent of b times a to the exponent of what? C. So I'm just going, remember here I'm just going in what? In reverse. Right? I'm going in. For mathematics, if in case you are able to go forward, you must be able to go what? Back. Remember that you are used to multiplying powers of the same base, right? And then adding the exponents. But then you must also be able to see that whenever I'm adding two exponents with the same base, I can separate those exponents and keep the what? The base. So now let us apply this. So let us apply this property. Let us apply. So it's going to be what? 2 to the exponent of what? 3x times 2 to the exponent of what? 3 plus 2 to the exponent of 3x times 2 to the exponent of what? Negative 2. Are we okay?
Yes, sir.
So now, coming here, do you see that 2 to the exponent of 3x is here and 2 to the exponent of 3x is there? So
Yes, sir.
let's go to another property of mathematics that you know. If in case I have a multiplied by b plus a multiplied by d, I can take out a as a highest common what? Factor by saying this is just a into b. I keep the sign plus what? D. Are you okay with that? So I'm going to apply the
Yes.
same property even here. So applying it here will lead us here. Check. I'm going to have what? I'm going to now take out 2 to the exponent of what? 3x. what am I going to be left with inside the bracket? I'm going to have 2 to the exponent of what? 3 plus 2 to the exponent of what? Negative 2. Are you okay? So here, this, you don't have to worry. You can just put it inside the what? The calculator. All of it. So I'm going to take my calculator and say 2 to the exponent of 3 plus 2 to the exponent of negative 2. It's going to give me 33 over 4. So my whole answer is going to be what? 2 to the exponent of 3x times what? 33 over 4. Which is the same as this is all over 1. So I'm going to have 2 to the exponent of 3x times 33 all over 4. Are you okay? So that can be our
Yes,
final
sir.
answer. So this is just a quick question. So I think we are now done. I think you guys now will be able to see the laws of exponents. So do you guys have any questions with regard to this question that we just solved?
No.
No questions at all. Any questions?
No.
No questions at all.
No question.
No questions.
No questions.
Yes, sir.
Okay. So let me try to do another one with you guys. Let me try to do letter J. I think after letter J, you guys will be fully comfortable with simplifying. So let me just copy and paste this. Okay. So now let's do letter J, right? So my tip was that you do what? Whenever you see the numbers, you just try to find the factors of these numbers from the calculator. So now you have 54, right? What is 54 equal to? I say 54 equal sign and then say shift fact. It's going to give me what? 2 multiplied by 3 to the exponent of what? 3. And then I'm going to do 36 now. 36 is just equal to what? 36 equals shift fact. It's what? It's simply, it's just simply 2 to the exponent of 2 multiplied by 3 to the exponent of what? Of 2, right? That's what the calculator gives me. And I'm gonna now say 24. Shift fact. The factors of 24 are just going to simply be what? 2 to the exponent of 3 times 3. So that is what we have. So wherever I see these numbers, I'm just going to substitute the values on the right. So my problem is now going to be what? Now going to be 2 multiplied by 3 cubed, all to exponent of what? X plus 1 times, where I see 36, I put what? 2 to exponent of 2 multiplied by 3 to exponent of what? 2, all to exponent of what? X minus 1, all over. Where I see 24, guys, you are gonna just click on the next link. Just gonna click on the next link as soon as Zoom kicks us out in like 10 minutes. So where I see 24, I'm just gonna put what? Substitute 2 to exponent of 3 multiply by 3, all to exponent of what? 2x minus 3. Are we okay? Let me move on.
Yes, sir.
So now I have 2 different bases all raised to the same exponent. So what am I going to do? I'm going to keep the base and give it that same what? Exponent. So here I have an exponent of 1. So it's going to be 1 times x plus 1, which is just going to be x plus 1. I still keep the sign of multiplication, and then I keep the base of 3. But then what is the exponent of 3? 3. So I'm going to multiply it by the exponent of what? X plus 1. So 3 multiply by x plus 1, it's just simply what? It's just simply 3x plus 3. So here I'm going to have exponent of 3x plus 3. Is that okay?
Yes, sir.
All multiplied by, here I'm going to apply the same thing. So it's going to be 2 to the exponent of 2, right? These are different bases, right? So I'm going to just keep the base of 2, but I'm going to take it to the exponent of what? X minus 1. So I'm going to have 2 to the exponent of what? 2 times x minus 1 is just going to be 2x minus 2. You understand that, right?
Yes, sir.
All multiplied by what? I keep the base of 3 and then I'm going to multiply this exponent of 2 by x minus 1. So it's going to be 2x minus 2. That is what I have currently, all divided by. All divided by. I still do the same thing at the bottom. So I'm going to have now what? 2. I keep the base of 2, but I have the exponent of 3. So I'm going to multiply 3 by 2x minus 3. So this is going to just be what? 6x minus 9. So I'm just simply saying 3 into 2x minus 3. So 3 times 2x is just going to be what? 6x. 3 times negative 3 is just going to be negative 9. So hence I have 6x minus 9. Here I just have an exponent of what? Of 1. So I'm just going to say multiply by what? Base of 3. But I'm going to multiply 1 by 2x minus 1. So it's going to be what? 2x minus 3. So that is the thing. So we are still on the same point, right? So you see at the top that we just have multiplication sign in between. Multiplication, 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 right? You notice that. So look, whenever we are multiplying, like let's say A times B times C times D, this is the same as me saying A times D times C times B. So the order of multiplication does not what? Does not matter, right? So I can multiply the first two terms or this one and that one or that, like the order in which I multiply does not matter as long as I'm multiplying. Are we on the same page, guys?
Yes, sir.
It's a law from mathematics. I do not make the laws, and the laws are not meant to be broken. These are mathematical laws. We do not break them. So this means that, check, I have a base of 2 here, right? I have a base of 2. And then I have another base of 2 here, right? And then I have another base, and a base of 3 here, and a base of 3 there, right? So this means now what I will want to do, I will now want to multiply this term and that term and this term with that term. So I want to multiply that ones with the same color. So let me do that. So let me continue. So I'm now going to have what? I'm going to rewrite this as being 2 to the exponent of what? X plus 1 multiplied by what? 2 to the exponent of what? 2x minus 2. Then multiply by 3 to the exponent of 3x plus 3. Or, yeah, is it 3x plus 3? Yeah, 3x plus 3. 3x plus 3 times 3 to the exponent of 2x minus 2 all over. I still keep the denominator, which is what? 2 to the exponent of what? 6x minus 9 times 3 to the exponent of what? 2x minus 3. So here, check, I'm multiplying exponent powers of the same base. So I'm just going to keep the base and add the exponent. So it's going to be 2. I'm going to have x plus 1 plus 2x minus 2. I'm going to have x plus 1 plus 2x minus 2. And I'm going to have multiply by, I still have the same base here. I'm just going to add the exponent, which is 3x plus 3 plus 2x minus 2. I'm simply adding these exponents. Even here, I added these exponents. All over, I still keep the denominator 2 to the exponent of what? 6x minus 9 times 3 to the exponent of what? 2x minus 3. So what do I do now? I just simplify my exponents. So it's going to be 2 to exponent of what? X plus x. X plus 2x is going to be what? 3x. 1 minus 2 is going to be minus 1. Then I have 3 to exponent of what? 3x plus 2x is going to be 5x. Then 3 minus 2 is going to be plus 1. All over. I still have now what? 2 to exponent of what? 6x minus 9 times 3 to exponent of what? 2x minus 3. Are we okay?
Yes, sir.
Okay. So now I want you guys to notice something else. Check this. I have 2 here. I have 2 there. Here I have 3 here. I have 3 there. Right? And then I have multiplication in between here and I have multiplication in between there. So there's this law now of mathematics that says if in case I have a situation like this of like, let's say A multiplied by B all over C multiplied by D, because I have this multiplication sign on top and at the bottom, I can just simply say this, it's A over C. I divide A and C, and then I keep the multiplication sign, and then I'm going to divide what? B by D. So I can still keep this sign of multiplication, but I'm going to divide these two, and I'm going to divide these two. This is a law of mathematics. You must know it from like grade 8, somewhere there. Are you okay with that? So I'm going to apply it even here. So I'm going to divide these two. I'm going to divide these two, but I'm still going to keep the sign of multiplication. So I'm going to continue and do that. So this is where I'm going to say here, I actually have what? I actually have 2 to the exponent of what? 3x minus 1 all over 2 to the exponent of what? 6x minus 9. All multiplied by 3 to exponent of what? 5x plus 1 all over 3 to exponent of what? 2x minus 3. You see? So now check what is happening. I have the same basis and I'm dividing. I have the same basis here and I'm dividing. So I can just minus their exponents. So I can continue. So I'm going to have, I keep the base of 2 and I'm going to have 3x minus 1 minus, I keep the bottom exponent in brackets, which is 6x minus 9. I keep it in brackets. And then I still have the multiplication sign, this one. But here I'm dividing powers of the same base. So I'm going to keep the exponent and keep the base and then minus the exponent. So I'm going to have 5x plus 1 minus into bracket 2x minus 3. Are we okay? So
Yes, sir.
I'm gonna simplify the exponents. So I'm gonna have 2 to exponent of what? 3x minus 1 minus 6x. But here it's negative. So it's gonna be this negative times this positive 6 is gonna be negative 6. Negative times negative 9 is gonna be positive 9. Then here I'm gonna still have multiply. So here I'm going to have 3 to exponent of what? 5x plus 1. This negative times this positive 2 is going to be negative 2x. Negative times that negative 3 is going to be positive 3. So I'm going to just continue now. Add. So it's going to be 3x minus 6x is going to be 2 to exponent of what? Negative 3x. And then negative 1 plus is going to be positive 8. Then I still have multiply by 3 to exponent of what? 5 minus